So starting with just graphing this, the first thing that I might start taking notice of is that we do have transformations. And this was a parent function. This was the original function that was like 1 over x that we did 2 sections ago. So this graph could be on your quiz. So if you do not know transformations, and I haven't taught them yet, you could just plug in any numbers you want. But when you plug in numbers, this might take you a while and you might get horrible numbers. So if you're just going to plug numbers in, be smart about it. Like think, what number could I plug in that wouldn't give me an awful answer? -4. If I plugged in -4, that would be like 1 over 1 plus 2. So I get 3. So if you're going to just plug random numbers in, let's plug easy random numbers in. Like numbers that'll make it easy on yourself. Or you can just plug in whatever numbers you want and just graph the horrible fractions that you get. If I'm plugging in random numbers, or if I'm using a transformation table, there is one number that when I plug in for x, it won't work. What number could I plug in for x that will not work with this graph? -5, because if I plug in -5, I'm going to get 1 over 0 plus 2. And you can't do 1 over 0, so you can't add 2 to it. This is undefined. What that tells me is when x is -5, that tells me we have an asymptote. X equals -5 is an asymptote, because x can't equal -5, right? So at x equals -5, we have an asymptote. So as I'm plugging in numbers, or if I'm using a transformation table, either way, we have to figure out that x cannot equal -5. -4, 3 was one of them. And if you're plugging in numbers, you might have gotten, I'm trying to remember what it was, -3, I think it's like 2.5 if you're plugging in numbers. And then if you're plugging in numbers, -6 was, is it 2? No. 1? What is it? Who plugged in -6? You know what? I have my notes from last class. Why don't I just look at this? -6 was 1. And then if I plugged in -7, you get like 1.5. So these are some easier ones that you'd have. But that's not enough unless you know what this picture looks like. That's not enough to graph it. So you might have to plug in some more numbers. But if you plug in more numbers, this is what's going to happen. Because I know you. You're not going to plug in a fraction if I ask you to do it on your own. You don't always think, let me plug in a fraction, right? Let's be honest. I wouldn't do it either unless I had to. If you did plug in -4.5 or -5.5, you would get a whole number. Let's see, this one would be 0 and this one would be 4, I think. So if you did plug stuff in, you'd get those. Or if you're using transformations and you know what the parent function should look like, the parent function should look like these branches. If you know from transformations what the parent function would look like, then you would have a better idea of graphing it. There's one thing from my graph I'm missing to make a really accurate graph. Some of you had it. What am I missing from my graph before I connect these dots? I'm missing another asymptote. There is no possible way that I can plug a number in 1 over x plus 5 and have it equal 0. There's no number that would make that equal to 0. Because there's no number that would make it equal to 0, if I add 2 to that, there's no number that makes y 2. There's absolutely no way that I can make y 2. That's why we have an asymptote here at 2. So then these are getting closer and closer and closer to the asymptotes, but they do not cross the asymptotes. That's what the graph would look like. If I give you one of these on the quiz, it's not going to be a super complicated one with hard numbers. It's just going to be basically like, do you know what the shape should look like? Can you find some points on it? This one has, if it's 1 over an x, it has 2 asymptotes. So it can make these branches. All right, domain and range. Let's talk about set notation, which is what you're getting quizzed on. And then we'll add in interval notation as well. Set notation, the domain, how far to the left does it go? How far to the right? Which x's can I use for my domain? Is it all real numbers? Gage? What can't I use? X cannot equal -5. Remember, I kind of wrote that over here. That's why I've been asymptote. So if I'm using my domain and I'm doing set notation, I'm going to write x does not equal -5, meaning it's everything except -5. How about my range for set notation, the thing that will be on the quiz? Up and down and up. Is it all real numbers? Ethan? Okay, so how would I write that over here? Perfect. So that's set notation. Now we're going to do interval notation. So this is what's new today, interval notation. Up here, I have all kinds of different examples where if it was x is less than or equal to 6, this is how you'd write it in interval notation. I have all kinds of examples right here. In the directions, we use parentheses anytime a number is not equal to, where it's just greater than or less than. We're going to use parentheses. We use brackets if it's greater than or less than and equal to. So if it can equal it, you use brackets. If it's not equal to, you use parentheses. The first number and the last number are end points. They're where does it start, where does it end. But keep in mind that infinity is not an end. So we use parentheses for infinity because it can never technically equal infinity. It can just be that direction. So when I look at this example, x is less than or equal to 6, that's telling me it goes all the way down to -infinity and it stops at 6. It can equal to 6. So here I start at -infinity and I go to +6 and I have a bracket because it can equal 6. Interval notation always goes smallest to greatest, least to greatest. I'm going to write that. Interval notation always goes least to greatest. Where set notation is usually talking about the variable first. So we have lots of different examples. All the way at the bottom, this example, x does not equal 6, that's the one that we were just working on. If x does not equal 6, that means that we have two pieces, we have two sections, we have two intervals of what x could equal, and then we hold them together with a union, which stands for to unite in holy matrimony. No. Bring them together, union, that's what the U stands for. So if I have an asymptote like I do here, then there's going to be a part on the right and a part on the left. You're going to have two parts. Over here on the left side, over here on the right side. You're going to have two pieces. They're going to be held together with a union. So my domain in interval notation starts at -infinity, goes to -5. It is not equal to -5. Union starts at -5, goes to +infinity, but it's not equal to infinity either. So we use all parentheses. And then my my range for interval notation would be -infinity to 2, union 2 to infinity. So we're just skipping over -5, we're skipping over 2, the two pieces held together with a union. All right. Question B. I'm going to do this one using transformations. Again, I like the transformations. You're going to learn them next couple classes if you didn't know them before. If you don't want to use transformations on the quiz, you don't have to. You can just plug in numbers for x. But I'm going to use transformations because I like how it gives me the end point. So for transformations, I'm going to start with the parent function, points, which is just like pick x's and then square root them. So I'm going to pick x's that I can square root. And then if we're doing transformations, what does the -4 do to the graph?
Moves it right.
Moves it to the right 4. So on the x side, I add 4. And then I graph my new x's and my original y's. 13.3 is off the graph, so I won't even graph that one. So that kind of stuff will be on your quiz, but again, you don't have to do it with transformations. Just want to keep telling you, you don't have to. It's just my method I choose. We do need to find domain and range. For the quiz, it'll be in set notation, so we'll find that one first. What's my domain? How far to the left, how far to the right? What do I know about the x's? X is what? Greater than equal to 4. Y is greater than equal to 0. So that would be on your quiz. Interval notation is new today. Interval notation. That won't be on the quiz. Don't put your answers in interval notation on the quiz. To do interval notation, we're thinking how far to the left, how far to the right does it go? So when we look at x's, how far to the left? It begins at 4. And because it equals 4, we use a bracket. How far to the right? Infinity. Parenthesis. Range. How far down? Begins at 0. How far up? Goes to infinity. Parenthesis. So that's the interval notation. It's the only thing new today. Yay. Next question. Some of us can do transformations without a table even. So I'll do this one without a table. If you need a table, use a table. Some of us can do transformations without a table. If you know your parent function is what for this? Oh, maybe we need a table. What is this one? Do you guys know what it's called? What are you doing? Oh, times 2? What were you doing over there? I want to learn the dances. Quadratic. It's squared. It's going to make what kind of shape? The U shape. If you know where all the points are and you can replicate those without making the table, fine. If you are making the table, I would highly suggest you go from -3 to +3 because no offense, you're not very good, you collectively as students I've had in the past. This year might be different, but you're not very good at drawing parabolas without a lot of points. No offense. So having more points just makes it more accurate and better. So if you're using these points, if you're using the transformation table, go for it. If not, all I know about this parabola is, what's this negative sign tell me?
Faces down.
It faces down, it's flipped down, reflected. And then what's that +1 tell me? It's moved up 1. So my vertex for the parabola will be here. And then it's going to be the same kind of like ratio between the points that it always is, because there's no stretch or shrink on this because I gave you an easy one. It's just facing down up 1. So you could do it without a table, or if you are using a table, you would want to multiply by -1 first and then add 1 in the table. Your third option for graphing this is just plugging in any x's you want and finding the y values. If you don't know how to graph something, that's how you should always do it at first, if you don't know how to graph something. All right, but that's review for our quiz. Review for our quiz, also set notation for domain. Left to right, how far does this parabola go? Forever. All real numbers. Range, down to up, does it go forever? No. What, Dominic?
Y is greater than or equal to 1.
So above 1,
Oh,
less than equal to 1. So that's set notation. Interval notation for all reals goes from negative infinity to positive infinity. Not equal to infinity, so parentheses. Range, it goes all the way down to negative infinity, comes up to 1, and is equal to 1, so bracket. So that's what the interval notation would look like. Okay, so the next one, I'm going to stop talking for a moment, and I want to see that you can graph it whatever method you choose. See if you can figure out your domain and range. Some of you have already done this one. I'm going to pause the video while you're working on it. Oh gosh, I hope it doesn't mess up the video. So question D, I used a transformation table. Some of you did transformations in your head. Some of you just plugged in random numbers, which is, any of those is fine. Our vertex is at -5, -3, and then goes symmetric from there. Domain is all real numbers, goes from negative infinity to positive infinity. The range, y is greater than or equal to 3. Remember, that's the stuff that will be on the quiz. And then not on the quiz, interval notation. Begins at -3 with a bracket, goes to positive infinity. Okay? Our last example is example E. And I gave you a hard one just to see who could do it. Example E, you can, what are my options for graphing? What could you do to graph it? Just plug in whatever numbers you want, but if you're going to plug in whatever numbers you want into a square root, maybe think ahead and make your life a little bit easier. You don't want to end up with the square root of a negative number, because then you can't graph it and you just wasted all that time. You probably don't want to end up with the square root of a number you can't graph either, like the square root of 17, which you wouldn't know how to graph. You know? So if you're going to pick random numbers, pick numbers that are going to work when you do the square root. What's another option besides pick random numbers to graph it? You could do translations if you remember them, transformations if you remember them, which is the way I'm going to do it, because I remember them. I'll teach it again real soon, I promise. If you're doing the transformations, then you want to start out with x's that you can take the square root of easily. So 0, 1, 4, 9, which is 0, 1, 2, 3. Those are the x's and y's I'm going to start out with. And then this negative on the, I'm going to go left to right. This negative on the outside says to take the y values and multiply by -1. And this -1 is not under the square root over here. This -1 says to subtract from the y values. That says it's going to shift down 1. This negative on the inside is a reflect vertically. That says take our x's. It's not a vertical. It's reflecting the y-axis. It's not vertical. I'm totally doing this left and right and saying vertical. Sometimes the wrong words come out. I meant horizontal. So we're reflecting this way. So you're going to take your x's and multiply by -1. And then after that, what do I do if there's a -2 with the inside of the function here? What do I do if it's a -2? Do I do -2? No, I do the opposite. I add 2. So anything on the horizontal side is like opposite operation. And then we graph the outside x's and the outside y's. Oops. So what I like about doing transformations is that we can find this endpoint really easy. Where if you're just plugging in random numbers, finding that endpoint may take you a while. So that's what I like about transformations. All right, domain, if we're in set notation, it goes to the left. So x is going to be less than or equal to what number? 2. And in set notation, the range goes down. So y is less than or equal to -1. Seriously, I had like 2 things left to write. I'm going to write them and then finish my video. You guys go to lunch. Just ignore me. We'll do it after lunch. In interval notation, we go from -infinity to +2, and it is equal to +2, so we use a bracket. For range, we go from -infinity to -1 equals -1, so we use a bracket.